Hello, so students, and welcome to your Mathematics 10 class. We're still under the topic of matrices. Today, we'll be looking at how we can find the inverse of a 2 by 2 matrix. I'm sure you're all expecting us to look at how we can solve simultaneous equations using matrices. But before we get into that, you must get very conversant with finding the inverse of a 2 by 2 matrix, as it will be very helpful in solving the simultaneous equation. So when we talk about an inverse, what do we mean? Well, an inverse is simply a thing that is the reverse of another. So let's say we had a letter such as A, and we were asked to find its inverse. We would simply find the reverse of A. I'm sure you know that A is equal to A over 1. So when finding the inverse, this feature is very important, as we are going to reverse the denominator and the numerator, or simply switch them. And hence, the inverse of A will be equal to 1 over A. If we had numbers such as 7 over 2, and we're asked to find the inverse of 7 over 2, it will be simply the same thing. We are just going to switch our numerator and denominator, and hence the inverse of 7 over 2 is 2 over 7. So this is what basically the inverse is when we talk about numbers. But how do we find the inverse of a matrix? Are we going to find the inverse of each of the elements? No. There's a way in which we find the inverse of matrices. And in today's lesson, that's what we'll be covering. So, to find the inverse of a 2 by 2 matrix, we use the determinant and the adjoint of that matrix. So, basically in syllabus D mathematics, the furthest they'll go is asking you about the inverse of a 2 by 2 matrix. So don't worry much about how you can find the inverse of a 3 by 3 matrix. Just worry and practice how we find the inverse of a 2 by 2 matrix. You should know that the inverse of a matrix is denoted by the symbol a to the power negative 1. The letter in this denotation or denotion is simply the letter of the matrix we've been given. So this letter will change. It might be A, it might be B, C, Z, and many other letters of the alphabet. But the inverse will be denoted by our negative 1 in the superscript. So let's say we were supposed to find the inverse of A. As we have said, to find the inverse of a matrix, we're going to multiply the inverse of the determinant and the adjoint. So, like I said, we had the matrix with the name of A. So we'll say A inverse using our symbol used to denote the inverse is equal to the inverse of a determinant. If you can remember our symbol for determinant, it had two bars and the name of or the letter of the matrix in the middle. So the determinant of A is simply two bars and A in the middle. And so the inverse of the determinant will be 1 over the determinant, like that. As you can see, this was the symbol we used to denote our determinant. So 1 over determinant is the inverse of the determinant of A. Don't get confused by the many ways that have been said, but so A inverse is equal to 1 over determinant multiplied by the adjoint. You can remember how we found the adjoint. We've covered that in our previous lessons. Yeah, so this formula that is shown here is basically the formula we use to find the inverse of a matrix. Now, let's look at an example so that we just clear the whole lot of explanation that we've covered. So, given that B is equal to this matrix that is shown and D is equal to this matrix, find the inverse of B and D. So, our first thing is finding our determinant. So, the determinant of B is 4 minus 3. So basically the determinant of B is the determinant of B is 1. So we'll say determinant of B is equal to 1. The inverse of B is equal to 1 over determinant multiplied by the adjoint. If you remember, we found the determinant of B, which is 1. So we'll simply say inverse of B is equal to 1 over 1. So the determinant was 1 and we replace this part with our 1. Then we simply find the adjoint of that same matrix. Yeah, so we switch and change the signs. Yeah, so 1 multiplied by that simply is this. And so the inverse of B is this matrix. Now let's move on to D. So as we did for B, we'll first find the determinant. So determinant is equal to 6 multiplied by 2, which is 12 minus 12. So our determinant for D is 0. So if we were to replace it into this formula, we would find that there will be 1 over 0. So 1 over 0 is simply 0. And if we multiply our 0 by the adjoint, we'll have 0. So D does not have an inverse. Matrices that don't have an inverse are called singular matrices. As we earlier described, a singular matrix is a matrix that has a determinant of 0. And as you may have seen, the singular matrices have no inverse. Some more examples apart from the matrix D that we had is this matrix. If we multiply 10 and 1, we'll have 10. And if we multiply minus 5 and minus 2, we'll have 10. So 10 minus 10 gives us 0. Hence, this matrix is a singular matrix. And hence, it will have no what? Inverse. Yeah. Now, this shows another matrix. If we find the determinant, we'll find that it's 0. So it's a singular matrix and has no inverse. So that's all for today's lesson. But practice how we find the inverse of a matrix. It will be very helpful when we start using matrices to solve a simultaneous equation.